Let's look at the functions worksheet. Number 4, the x values repeat, -3 and -3, so this is not a function. On number 5, the y values repeat, but that has nothing to do with determining if this is a function or not. You only look at the x values. And what do you notice? They don't repeat, so this is a function. On 6, the 6's in the x column repeat, so this is not a function. Number 7, if I draw a vertical line here, here, and here, and here, I only hit the scatter plot one time each time I draw the vertical line. So this is a function because it didn't repeat. But if you notice on this one, I can draw, oh, I'm sorry, I did that wrong. This line extends, doesn't it? It sure does. And guess what? Since this one vertical line hits this line, this dot, and this dot, this is not a function. I'm glad I caught that. Sorry about that. This here, draw one line, one line, one line, one line, one line, one line, one line. It only hits each dot once. So this is a function. So what did we just learn about number 7 and number 8? We should draw our vertical lines all the way down to make sure that it doesn't hit any other points, because I drew my line halfway and then drew another line, and that's incorrect. So be careful about your vertical lines. Make sure they go all the way up and all the way down. So if you do see another point, or if there is another point, you'll see it. Okay? So this one's not a function because I drew it all the way down. I see 2 dots. I drew my lines all the way down, and they only hit one at a time, so this is a function. Let's practice using the vertical line test on the back. If I draw my vertical lines all the way down, what do you notice? Is it hitting the graph more than once? Well, there it hits it twice, there it hits it twice, there it hits it twice. Now, for those that are saying, but if you put it here, it only hit it once. You're right, it does. But because it hits it twice here, and hits it twice here, and here, this is not a function. Let's look at this one. If I draw a vertical line here, how many times does it hit? It does hit it 13 times, which means it's not a function. Okay? But if I drew this as the problem and asked you, is it a function or not? Hopefully you would still say, no, it's not. And if I asked you, how many times does a vertical line hit it? Hopefully you don't say 13. See, this one had dots, and it wasn't connected, but this one's connected. So how many times does the green line actually touch this black line? So many times you cannot count. So this one touches it infinitely. This one only touches it 13. But both of them are still not functions. Now on this one, if I draw vertical lines through it, I missed it, sorry. Let me slow down because I missed it. There we go. Did it touch more than one graph at a time? Or more than one point at a time? And no, it did not. So this is a function. Now, if you draw a horizontal line through these points, this is what we call a y value. 1, 2, 3, 4. And that's y equals 4 if you draw the line and connect the dots. Which means this here, if you draw the line and connect the dots, 1, 2, 3, 4, 5. This is x equals 5, and this one would be x equals 1. Remember, x values are vertical. So when we are using the vertical line test, what are we doing? We're drawing x values. We're just checking to see if the x value is going to repeat or not. And right here it repeats 13 times. Right here it repeats it so many times you cannot count. And here the x value never repeated because the vertical line only touched the graph one time. So we're really drawing the cracks in the sidewalk that we talked about. When you're walking on that sidewalk and you see that crack, that's your x value. Like x equals 5 and x equals 1. So these are x values. These are the cracks in the sidewalks that we're graphing to check to see if it's function. So here, it touches it once. Here, touches it once. What can we say about this one? It is a function. Here, I know you may not understand what this is, but it's called a mapping diagram. And when you have a mapping diagram, you should draw it out as a table or order pairs. And so 5 has an arrow to 4, and this is x and that's y. So this is 5, 4. 18, 9. 14, 3. Excuse me. 14, 6. Come on, Miss Pierce, stop making mistakes. It happens. I need to slow down. And 75, 3. So only look at the x values. Do they repeat? No, they do not. So this is a function. So now this scatter plot stuff we got to be careful with because we made a mistake earlier. Draw it all the way down and all the way through. I'm going to skip that one. And there it is right there. I see it hits it twice. So this is not a function. The x value repeats 4 times, so this is obviously not a function. I see -3, -3. This is not a function. This repeats, not a function. The x value repeats, not a function. So I know you see that the 2 repeats here, but does it matter what the y is doing? No, only what the x is doing. It's still not a function, but it doesn't matter what the y is doing. You only look at the x. Alright, now let's look at 1, 2, and 3. Remember I told you when you have a mapping diagram, go ahead and write the points out or make a table. So this is 1, 7, 2, 7, 3, 7. And this is x and this is y. What's going on with the x values? Do they repeat? No, they do not. So this is a function. So it's the opposite. When x values repeat, it is not a function. When the x values do not repeat, it is a function. Just as simple. So number 1, let's make a table for that. X and y, x and y. A goes to 4, B goes to 2, B goes to 1. This is not a function. And for this one, San Francisco is going to the Giants. New York is going to the Giants and the Mets. And so if we assume that this is X and this is Y, which is what we're asking you to do, can New York go to the Giants and the Mets? No, so this is not, because that means New York is repeating. How do you know? Make your table. San Francisco to the Giants, New York to the Mets, New York to the Giants as well, and then St. Louis to the Rams. See, the x value is repeating, so that's not a function. Now I want to go over the worksheet that you had to do about is it a function. There were 3 problems on there. So let me get that worksheet. Hopefully I can get one that is not written on. I should have had it by my seat. Hold on. Let me go run and get it. Sorry about that. Here it is right here. Okay, so we want to figure out what is this talking about. Marissa believes the mapping diagram below is not a function because all the domain values are mapped to the same range value. So, first let's write this out using ordered pairs. That would help me create a relation. So this is 3, 2, comma, 5, 2, comma, -3, 2. And you just made your relation. That's what a relation is. So now put those points on the graph. 3, 2, 5, 2, -3, 2. And now what we do is connect this. Who remembers what this is? Isn't that a y value? Yep, y equals what? 2. And how do we know? Because it crossed 2 on the y-axis. Now, the domain is nothing but what's in the x column, or the x oval in this mapping diagram. So the domain is 3, 5, negative 3. The range is just 2. Some of you put 3 2s, and that's okay. The input value, x, the output value, y, meaning range for y, domain for x. The domain was 3, 5, and negative 3. The output was 2. So now when you look at the table, the x value is not repeating. So this is a function. X value not repeating. It is a function. The domain did not repeat. It is a function. Draw a vertical line through the graph, and nowhere do you see it hitting it more than once. So this is a function. So there are so many things you can write in a statement. The range depends on the domain. The output depends on the input. The y values depend on the x values. And how do we know if this is a function? Determining if it is a function depends on if the x values repeat. And so all of those could have been answers. You could have put the horizontal lines depend on the vertical lines. Use the vertical line to prove why the graph is a function. Done. It only hits the graph once. So is Marissa correct? Well, she said that this is not a function, and she's wrong. Is she correct? No. And the reason she is incorrect, or the reason she's not correct, is because the x values did not repeat. It doesn't matter what happens to the y. The x values did not repeat. So now we look at question 2. If the problem becomes this, is it still a function? Okay. Well, this says 2, 3, 2, 5, 2, negative 3. So I'm going to put that in the table. And then I'm going to write my relation. And then I'm going to write my domain and then my range values. And when I graph this, it's 2, 3, 2, 5. Just a moment. And 2, negative 3. And when I draw my line, this is a vertical line, meaning it's x equals 2, an x value. Is this a function? Well, the x values are repeating. The domain is repeating. The x values in the relation are repeating. If I draw a vertical line through this, what happens? It hits it more than once. It's not a function. It doesn't just hit it 3 times. It hits it all these other times. So this is not a function. And the answer to this is the same as on the first page. The vertical line test, we just proved it. And so, if Marissa still believes the mapping diagram above is not a function, is she correct? Yes. And that's because the x values now, they repeat. Okay, last but not least, number 3, I did not go over today in class. We're going to save this for the 15th and the 16th and incorporate it inside of the lessons then.